Good afternoon. It is Tuesday, April 4th, 2023. And this is a little brain exercise. So have a quick look and see what you think. So we've been asked to give some thoughts to an engineering academy, high school engineering academy. Seniors working on a design project. They're using ThermoElectric coolers, and I believe what their thought was to make a cooler seat for a chair. I think that's the application. Could be wrong, but anyways, I felt inclined to give it a try. They had asked if I had any inclination as to how the mounting might go. Again, I'm not a thermal engineer, but sometimes it's good just to be creative and cut some pieces of things and tape them together and see what happens. Okay, so like obviously this would be a piece of metal, a cold plate, and probably need some type of thin cushion, but you don't want to, it shouldn't be a thermal resistance because then it won't do its job of cooling. And then it has this lattice here of like 1.5 inch pieces. And what would happen is the air, ambient air, would come in this way and would exit out this way. And there's a baffle on the bottom, there's a baffle in the middle to separate the hot air exiting from the ambient air coming in. There's insulation to separate ambient air from probably like 60 degree or 55 degree, somewhere in there, cold plate on top. Maybe this shows it a little bit better. So this insulation, this is cold. This is ambient air coming in here to a heat sink that's on the device. And there's a fan underneath that then pulls the air down through and then exits out this way. I think we're going to bring it up for a little bit more detailed explanation. I think we're going to flip it over. So this bottom piece is a baffle just to keep the airflow going in the right channels. And then we can see here, this is a baffle in here to separate the ambient air coming this way. The hot air, the fan would be drawing the hot air up through the heat sink, and then it would exit this way off to the side. Cool air, ambient air coming this way, hot air going out that way. So let's take off this baffle. It doesn't have to be thin. This is just paper. I suppose it could be very thin material of paper, whatever. It just needs to separate hot air from cold air. I don't know that necessarily needs to be insulation per se. So this is like the stack. The lattice is thermally non-conductive. We don't want temperature from the cold plate to get down into the hot section. So this would have to be something insulating like wood, can't be metal. And let's take a look at the stack. So the thought was that it would be secured to the underside of the cold plate. So this is bolted to the cold plate. When someone sits, they're not sitting on the device. The lattice is supporting all the weight. So when you sit, the weight is transferred through the lattice structure to the seat. It is not pressing down on the thermoelectric module stack that's bolted to the top, and there's clearance on the bottom so that this doesn't crack due to people sitting, motion, things like that. Alright, so we're gonna, again, this is just stuff that was in the basement, so this isn't final design. Yeah, so this is just, you know, one thought of what might work. I don't even know if it's the right application, but felt compelled to do this, so I did. So I rubber banded this stack together just so it would come off as a piece. There we go. So this is the bottom of the cold plate. Yep. It came out. And there's insulation here to keep the cold plate cold, insulated from the ambient air chamber. And then this, let's see, on this side, here's the ThermoElectric module with the red and black wire. It's like an 1/8 inch thick. And then here we have a cold block. And the need for this piece is to have some room for insulation. If you put the ThermoElectric module cold surface right against here, there's no room for insulation between the cold and hot air. So this is just a spacer, a metal spacer, good thermal conduction, attached to the, well, sandwiched to the cold side of the ThermoElectric module. And the hot side of the ThermoElectric module is a heat sink. So air would come in through the heat sink and the fan would pull it out this way. So the fan, instead of blowing on the heat sink, it's going to suck the heat this way. So that's how the stack is. And if we turn it upside down, this is the cold plate, the cold spacer, the ThermoElectric. Air is being, comes in this way, yep, comes in this way, sucks down, and then exhausts out this way. And we made the heat sink and cold spacer and fan larger than the ThermoElectric module, which is 1.5 inches, so that we can bolt this whole stack together onto the cold plate, so it sandwiches it together. Good thermal conduction for all the pieces. Will this idea work? I have no idea. It just came to me, so I thought we're gonna try it. So let's there we go. We got the stack against the cold plate. We got the insulation in. We need to do our baffle that goes between the ambient and the hot discharge air. So the air is going to come underneath here, be sucked up through the fan, and then exited out this way. And this would be the bottom, just a baffle, air baffle, so that the hot air will exit this way and not come back around into the ambient air inlet. So this is just one ThermoElectric module. You can have, you know, easily you can do 1, 2, 3, 4, 5, 6, 7, 8, 9, or any combination thereof to get the heating capacity that you need. We got our wires that will go to the power supply for the controller, and wires to go for the fan. Put our baffle in, bottom baffle. And let's once again sit like this on a chair. Perhaps, I don't know. This is, you know, just one of those thoughts that came in. So If anyone has good comments about what would be a better way to thermally physically mount thermoelectric modules to cool a seat, please feel free to chime in.